all connect? Are they really well connected? Are they somewhat, or are they not at all connected?
Somewhat.
Somewhat, very good. Yeah. So these are the guys that are somewhat connected. They're not very strong, and they are non-metals only. Okay? From shocking revelation, could these compounds conduct electricity?
Wait.
Take a moment, that's fine. So give me a hint, we talked about these, and we talked about another type of compound.
I know they have to be like metal and non-metal.
Okay, what, the ones that are, so these, okay, so if you're telling me the ones that are metal and non-metal, if they're metal and non-metal, what do you know about them? Metal, huh? Yeah, the ionic ones, the metals and non-metals, what do they do with the light bulb?
They make it light up.
Yeah, ding, they make it light up. These guys do not, okay? These guys do not. These are non-metals only. Where are the non-metals located at in the periodic table? Sorry, what? It's the right side, yeah. There's only one exception to that, hydrogen. Hydrogen is a non-metal. It's on the left side, but hydrogen's kind of a weird one. It's put in with column 1 because it only contains one electron in its outermost level, but at the same time, it only contains one electron, period. So it's one electron short of being a noble gas like helium. So when it gains an electron, it becomes just like helium. So really, it's almost kind of as if it should be in column 7. The only problem is it only has one electron in its outer shell, not 7 like the rest of them do. So that's why hydrogen's on the left, but hydrogen is a non-metal. And then I assume, hopefully you guys have in here, like which ones are the semi-metals. I think we went over that in class as to which ones are like the semi-metals. So like the ones that are on the right-hand side here, the stair step that follow right alongside it, they are. And then with the exception of aluminum, the ones that bordered on the left-hand side too are also semi-metals or metalloids. Meaning that they can also be a part of these types of compounds, or they can also form ionic compounds. They can do one of both. Okay, so these are molecular compounds, they're non-metal only. And I've got in parentheses here that these compounds can be polar, or they can be non-polar. We discussed from shocking revelation that they are, we can determine whether they're polar or non-polar based on their electronegativity difference in the elements. If that difference is between 0.4 and 1.7, it's polar. But if it's less than 0.4, it's non-polar. And these guys, instead of being like ionic compounds, where one gains a charge and becomes negative, it gains an electron, becomes negative, and the metal loses an electron and becomes positive. So instead of the giving and taking of electrons, these guys share them. If they share them unevenly because of that electronegativity difference, they're polar, meaning that they have, again, a partial positive and a partial negative charge. Okay? Those are polar. The ones that are non-polar share them pretty much even, Steven, 50-50. They share the electrons equally when they make a bond. So that is just a brief overview of molecular compounds in terms of what they are, from what we've already discussed from shocking revelation and from our crystals activity on the computer. So that's just kind of a brief overview as to what that all is. Now, in terms of naming and writing formulas. Okay. Now, when you see the chemical formula, you still name the elements as they are. The first one you just flat out name the element. If there's only one of them, you don't have to put a number prefix in front of it. But if there's more than one, like in this one, then you put a number prefix in front of it. The second element, you're always going to put a number prefix in front of it. It doesn't matter whether it's 1 or 10. Okay, so PBr3 is phosphorus tribromide. So I didn't have to put a mono in front of it. It's the first one. If it's the first one and there's only one, you just have to call it by its actual name. You don't have to put the number prefix in front of it. Now for bromine, there's 3 of them, so the number prefix tri goes in front of it. Phosphorus tribromide. P2O5. Okay, the first one, there is more than one, so we do have to put a number prefix in front of it. So diphosphorus. And then for the oxygen, we would name it oxygen. We drop it at the suffix, which the Y counts as a vowel. So we're dropping it at the Y, just like any other type of compound, such as, carbon dioxide. So we drop it at the Y, and it's oxide. There are 5 of them. So pentoxide. Now you're probably wondering, why not pentaoxide? It's one of those funky English language rules things that they don't like to put in naming it. They don't like to put 2 vowels in a row. Why that is, I don't know. At least they don't like to do it that way when they came up with the naming system, that being the scientists. So they dropped the A out of it, and they just made it pentoxide. So pent meaning 5. And you'll notice I've got all the number prefixes over here. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. 1 through 10. You won't have any more than 10. At least for what we're doing.
Is it 12 dodeca or something?
It's 12 what?
Dodeca?
Yeah.
Okay. I honestly don't know. I'm not familiar. I'd have to look it up. I don't know my number of prefixes past 11. I probably once did, but I've just not had to use it for a long, long time. Okay. So another example I did over here, CCl4. There's only 1 carbon, so since it's the first one and there's only 1 of them, I don't have to put mono in front of it. Carbon, and then there's 4 of the chlorines. So tetra, carbon, tetra, chloride. It's 1 carbon, 4 chlorines, carbon, tetrachloride. CO, classic one, carbon monoxide. Instead of it being monoxide, again 2 vowels in a row, they drop the vowel at the end of mono, they just make it monoxide. 1 carbon, so they didn't have to put mono in front of the first one, but you do always put mono in front of the second one if there's only 1 of them. P2S3, diphosphorus, because there's 2 phosphoruses, so diphosphorus, and then 3 sulfurs, trisulfide. Diphosphorus, trisulfide. So really the big difference between these and ionic compounds is the fact that with the molecular compounds, molecular, covalent, whichever one you want to call them, number prefixes. That is basically how they're able to differentiate between the two. If you're using number prefixes, that means we have these molecular covalent compounds. If there are not number prefixes, it means we have ionic compounds. And also in the formula, you can tell by the formula, because you have to look in the periodic table, if you have nonmetals only in your compound, it is a covalent compound. But if you have a metal with a nonmetal, it's an ionic compound. And the cool thing about let's say if they give you the name and you're asked to write the formula, the work's already pretty much done for you. Because you have the element names here, and the number prefixes tell you how many. So if I were just to see carbon tetrachloride, well, 1 carbon, 4 chlorines. 2 phosphoruses, 3 sulfates. 1 carbon, 1 oxygen. 2 phosphorus, 5 oxygen. 1 phosphorus, 3 bromine. Let's try one more on this size. Let's see. How about SF2? SF2. So SF2. So what's S?
Sulfur.
Sulfur. Do I call it monosulfur or just sulfur?
Sulfur.
Sulfur, yeah.
Difluorine.
Difluorine or difluoride. Yep. Drop the INE, add IDE. Very good. Sodium, I'm sorry, sulfur, difluoride. I didn't know I said sodium.
That'd be an interesting combination.
Well, actually, sodium fluoride is a common chemical. Find it in toothpaste. Yep. You do find sodium fluoride, I do believe, in toothpaste. So you do need a little bit of fluorine. It helps to clean your teeth. You also know they put fluorine in your drinking water. If you live in any type of town in the U.S., so if you live in an incorporated town that has its own water system, which Kowalski just got its own water system in town, what, 3 or 4 years ago, so Kowalski's no longer an exception to the rule either. Every town that has its own municipal water system, they put a little bit of fluorine in the water. It's to help improve dental health. Helps to clean your teeth even just a little bit. So even if you didn't brush your teeth, which is a bad thing, you still would have a little bit of dental health there because they do put a little bit of fluorine in the water. Yeah. So anyway, sulfur, difluoride. Okay. Questions?
Nope.
No? Okay. Your assignment then, there were 2 worksheets that were shared with you. One of them was worksheet 4, titled Molecular Compounds. And the other one was titled Naming Covalent Compounds. Okay? Naming covalent compounds. So, the nice thing about it is they're both just one-sided. So in a sense, it's kind of like you really only